In this video, we are going to study partial differentiation. We know that in a function denoted as y equals fx, x is independent variable and y dependent variable because value of y depends upon value of x, and we denote derivative of y with respect to x as dy by dx or f dash x, which denotes rate of change of y with respect to x. Here y depends upon a single variable x, but there are functional relationships where the dependent variable, say z, depends upon two independent variables x and y. If we want to measure change in z with respect to change in x or change in y, then we either have to keep x fixed, measure change in z with respect to y, or number 2, keep y fixed and measure change in z with respect to x. The first change is denoted by partial z by partial y, and the second by partial z upon partial x. Here, instead of using d, we use a rounded d known as do, daba, or simply partial. So let us learn more about this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Let us recall differentiation. Let y equals fx be a function of single independent variable x. Suppose x changes to x plus delta x, y will change to y plus delta y. So we have y plus delta y equals f of x plus delta x. Delta y will be f of x plus delta x minus y. But y is fx, so it will be minus fx. Dividing both sides by delta x, it will be delta y upon delta x equals f of x plus delta x minus fx upon delta x. Taking limits on both sides, as this delta x tends to 0, it will be limit delta y upon delta x. As delta x tends to 0, will be limit f of x plus delta x minus fx upon delta x, as delta x tends to 0. This limit of delta y upon delta x as delta x tends to 0 is special limit known as dy by dx, or derivative of y with respect to x, which is limit f of x plus delta x minus fx upon delta x as delta x tends to 0. So dy by dx, or derivative of y with respect to x, is a special limit f of x plus delta x minus fx upon delta x as delta x tends to 0. Let me correct here. This should be delta x tends to 0 and not x tends to delta x. Now let us discuss partial derivatives of the first order. Let z equals fxy, a function of two independent variables x and y. Suppose now x changes to x plus delta x, y remaining constant. Then z will be z plus delta z. Therefore z plus delta z will be f of x plus delta x y. Therefore delta z will be f of x plus delta x y minus z, which is f of x y. Delta z upon delta x will be f x plus delta x y minus f x y upon delta x. Now taking limits on both sides, limit of delta z upon delta x as delta x tends to 0, if it exists, is called partial derivative of z with respect to x, and it is denoted as partial z upon partial x equals limit f of x plus delta x y minus f of x y upon delta x as delta x tends to 0. Now we consider partial derivative of z with respect to y. So y changes to y plus delta y, but x remains constant. Then z plus delta z will be f x comma y plus delta y. Therefore delta z will be f of x comma y plus delta y minus z, but z is f of x comma y. Now delta z upon delta y equals f of x y plus delta y minus f x y upon delta y. Now taking limits on both sides, as delta y tends to 0 will be partial derivative of z with respect to y, and we denote it by partial z by partial y equals limit f of x comma y plus delta y minus f of x comma y upon delta y as delta y tends to 0. Use definition of partial derivative of z with respect to x to find partial z by partial x of z equals x square y, a function of two variables x and y. Now according to this definition, let x changes to x plus delta x. Then z will change to z plus delta z. Therefore z plus delta z will be, according to this function, x plus delta x whole square into y. Therefore delta z will be x plus delta x whole square y minus this z, but this z is x square y, so this will be x square y. Now by using this definition, dou z by dou x will be limit delta z upon delta x as delta x tends to 0, that will be limit this x plus delta x whole square y minus x square y upon delta x as delta x tends to 0. So dou z by dou x will be limit x square y plus 2x delta xy plus delta x square y minus x square y upon delta x as delta x tends to 0. This will be limit x square y minus x square y 0, 2x delta xy plus delta x square y upon delta x as delta x tends to 0, which is limit delta x tends to 0. Now as delta x tends to 0, delta x is not equal to 0. Therefore 2x delta x y upon delta x will be 2xy after cancelling delta x plus delta x square y upon delta x will be delta xy after cancelling one delta x. So this will be 2xy because 0 into y is 0. So therefore dou z by dou x is 2xy. We can find this without using definition also. We have z equals x square y. So dou z by dou x is partial derivative of x square y with respect to x. So we will use product rule accordingly. First function x square into d by dx of y plus second function y into derivative of the first d by dx of x square. When we are partially finding derivative of x square y with respect to x, we are treating this y, that is this y, to be a constant, and derivative of constant is 0. So therefore d by dx of y will be 0 plus y into derivative of x square is 2x, which is 2xy. So dou z by dou x is 2xy, which we have obtained here by definition of partial derivatives. Now we will see how to find partial derivative of z with respect to y, that is how to find dou z by dou y of function z x square y, which is a function of two variables x and y. Let y changes to y plus delta y, x remaining constant, then z will change to z plus delta z. So z plus delta z will be x square into y plus delta y. So delta z will be x square into y plus delta y minus this z, but z is x square y. This will be x square y plus x square delta y minus x square y. So delta z equals x square y minus x square y 0. So it will be x square delta y. Now using this definition of partial derivatives, dou z by dou y equals limit of delta z upon delta y as delta y tends to 0, which is limit x square delta y upon delta y as delta y tends to 0. As delta y tends to 0, delta y is not equal to 0. Therefore, this limit will be as delta y tends to 0, cancelling delta y, it will be x square. So, dou z by dou y will be x square. Now we will find dou z by dou y without using this definition. We have z equals x square y. We have to find dou z by dou y. So we will use product rule here. First function x square into d by dy of y plus second function y into d by dy of x square, the first function. This will be x square into derivative of y with respect to y is 1 plus y into in partial derivative of z with respect to y we treat x square as constant and derivative of constant is 0, so this will be 0. That finally gives us dou z by dou y equals x square, which is same as found by using definition dou z by dou y equals x square. We have seen how to find partial derivatives by using definition. It is lengthy and cumbersome. So now we are going to see how partial derivatives can be obtained without using definition. For a function z, which is a function of two independent variables x and y, when we want to find partial derivative of z with respect to x, we write partial z by partial x and we find d by dx of f of x comma y, treating y as constant. On the other hand, when we want to find partial derivative of z with respect to y, we write partial z by partial y and find d by dx of f x comma y, treating x as constant. So remember, when you are finding partial derivative of z with respect to x, we have to treat y as constant, and when we are finding partial derivative of z with respect to y, we have to treat x as constant. Pardon me, this should be d by dy instead of d by dx. Similarly, if z is a function of three independent variables u, v and w, in this case partial derivative of z with respect to u will be dou z by dou u, which will be d by du of f of u v w, where u and w are treated as constants. Partial derivative of z with respect to v will be dou z by dou v equals d by dv of f of u v w, treating u and w to be constants, and partial derivative of z with respect to w will be partial z by partial w equals d by dw of f of u v w, treating u and w to be constants. So remember, when it is dou z by dou u, you have to treat u and w to be constants. For dou z by dou v, you have to treat v and w to be constants, and for dou z by dou w, you have to treat u and v to be constants. Now let us see how do we do this. Let us find partial derivative of z equals xy square. Partial z by partial x will be, by product rule, x into d by dx of y square plus y square into d by dx of x, which is x. Since this is partial derivative with respect to x, we have to treat this y square constant, and derivative of constant is 0 plus y square into derivative of x with respect to x 1. So dou z by dou x will be y square. Next we find dou z by dou y. By product rule, x into dz by dy of y square plus y square into d by dy of x, which equals x into derivative of y square with respect to y, 2y plus y square into, since this is partial derivative with respect to y, we have to treat this x to be constant, and derivative of constant is 0, so here this will be 0. We get dou z by dou y equals 2xy. So we get dou z by dou x equals y square and dou z by dou y equals 2xy. Let us find partial derivative of z x cube y square. Dabba z by dabba x will be, by product rule, x cube d by dx of y square plus y square into d by dz of x cube, which is x cube. Here y square is constant, so its derivative is 0, plus y square into derivative of x cube, 3x square. So dabba z by dabba x will be 3x square y square. Now dabba z by dabba y will be x cube into d by dy of y square plus y square into d by dx of x cube, which is x cube into derivative of y square with respect to y, 2y plus y square. Here x cube is constant, so its derivative is 0. So we get dou z by dou y equals 2x cube y. How to find value of partial derivative at a given point. Suppose a function u is x square y square z, and we have to find partial u by partial x at a point 1 1 1. First, dou u by dou x will be, since we are finding partial derivative with respect to x, we have to treat y and z to be constants. So here dou u by dou x will be, by product rule, first function x square into d by dx of this group y square z, which is to be treated as constant, plus y square z into derivative of x square d by dx of x square. This will be x square. Derivative of constant is 0, plus y square z into derivative of x square with respect to x is 2x. So dou u by dou x will be 2x y square z, and dou u by dou x at point 1 1 1 will be 2 into 1 square into 1, 2. For finding dou u by dou y, we have to treat x square and z to be constant. So by product rule it will be x square z d by dy of y square plus y square into d by dy of x square z. That will be x square z into derivative of y square 2y plus y square. X square z is constant, so d by dy of x square z is 0. So dabba u by dabba y is 2x square yz, and dabba u by dabba y at point 1 1 1 will be 2 into 1 square into 1 into 1, which is 2. Finally dou u by dou z will be x square y square into d by dz of z plus z into d by dz of x square y, which is x square y square into derivative of z with respect to z is 1, plus z into d by dz of x square y will be 0, because here x square y is constant. So dou u by dou z is x square y square, and dou u by dou z at point 1 1 1 will be 1 square into 1 square, 1. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.